In this video, we're going to break down three main machine learning approaches: supervised learning, unsupervised learning, and reinforcement learning. And by the end, you'll have a simple way to tell which one fits a real-world problem. So let's first look at why these types matter in the first place. Well, in real projects, one of the first big questions is usually, what type of learning problem is this? So picking the right approach early can save time, money, and a lot of guessing. And one more quick mindset note before we start is the real skill isn't memorizing algorithms, it's framing the problem correctly. With that in mind, let's start with the most common machine learning types. Supervised learning. Basically, supervised learning is when you train a model using labeled data, meaning your dataset includes the correct answer for each example. And the model's job is to learn the relationship between the input and the known output. For example, you might predict whether an AWS bill will go over a set limit this month. And this is done using past cost data where the final monthly totals are known. Or you might sort support tickets into categories like billing, network, or security using older tickets that were already tagged. Most supervised learning tasks can be grouped into two main types based on what kind of output the model predicts: classification and regression. Classification is when the model predicts a category or label. For example, it tries to predict whether the output is a spam or not spam. It tries to whether the output is fraud or normal, or distinguishing cat versus dog. And regression is when the model predicts a numerical value. For example, a model for house price or temperature or sales amount. All right, so that's all about labeled data approach. Now let's look at what happens when you don't have labels at all. And that brings us to unsupervised learning. In other words, unsupervised learning uses unlabeled data, meaning you don't provide correct answers during training. Instead, the model tries to find patterns, a structure, or groups on its own. For example, you can think of a mix of raw data about traffic flows, and an unsupervised learning model automatically groups similar patterns together, such as normal traffic, heavy traffic, and unusual spikes, and all without being told what those groups are in advance. Or you might analyze network traffic flows to separate normal from unusual traffic. Unsupervised learning is often used for clustering, where the goal is to group similar things together, and association or pattern discovery, where you learn what events often happen together. So supervised is about learning from answers, and unsupervised is about discovering the structure. But there's a third setup where learning comes from outcomes over time. So let's move to reinforcement learning. Reinforcement learning is when you train an agent to take actions in an environment to maximize total reward. So the agent learns through trial and error. It takes an action, gets a reward or penalty, and improves its strategy over the time. For example, you can tune auto-scaling decisions, scale out versus scaling, using a reward signal like keep latency low while keeping costs reasonable. Or you can improve the order of steps in an automated workflow where the reward is faster completion and fewer failures. So that's the third category. Let's quickly compare how you even measure success across these three approaches. When you put them side by side, the big difference is what you're trying to optimize. Here's how success is typically measured. For example, in supervised learning, predictions match the labels as closely as possible. Unsupervised learning, the patterns found are meaningful and useful. And in reinforcement learning, the agent earns more reward over time by making better decisions. And once you know what you're optimizing for, the lists of common methods start to make a lot more sense. So let's run through a few names you'll hear all the time for each of these machine learning types. Here are some common methods you'll hear in each category. For supervised learning, linear regression and logistic regression, decision trees and random forest, and support vector machines. For unsupervised learning, k-means clustering, hierarchical clustering, and PCA, and for reinforcement learning, Q-learning, and deep Q networks. Now, you don't need to memorize this list. At this stage, the most important thing is to understand what each learning type is used for, not the math or the algorithms themselves. What matters more is knowing how to choose the right approach for your situation. If you can recognize this is a prediction problem, or this is a grouping problem, or this is a trial and error decision problem, you're already on the right track. So let's make that decision a bit easier. If you have the past data and known correct answers to learn from, use supervised learning. Some of the common use cases are predicting demand, sorting emails or tickets, detecting fraud. If you have data without labels and you want to explore, segment, or find patterns, use unsupervised learning. Some of the common use cases are customer segmentation, grouping similar workloads, spotting unusual patterns. And if you're making decisions over time and can define rewards and penalties, consider using reinforcement learning. And some of its use cases are resource optimization, robotics, and game playing agents. Alright, that's a wrap for this video, everyone. Now you may have a clear way to separate supervised, unsupervised, and reinforcement learning and have a simple mental model for when each one makes more sense. Thank you for watching. Please make sure you're subscribed to our YouTube channel, and I'll see you in the next video.